Okay, so this is kind of just a continuation of the batch, basic batch that I talked about yesterday, and I can see that at least the majority of people here were also here yesterday. So I'm going to assume that you know what was said then, and this is then going a little bit further to run a little bit more advanced Python scripts as batch jobs, also some repetitions. And you have just worked with matplotlib and pandas in the morning. And I know we have users who want to run them as batch jobs, so I'll just look at a small example of how you can do that. And then a little bit briefly about how you do virtual environments in batch jobs. So I have logged in here to Tetralit, and I'm going to just work in I need to have X11 forwarding, so I'm going to log out again, and then I'm going to log in with minus capital X. I don't need it for my first exercise, but I need it for the second exercise. Or rather, I just need it to show some part of it. So if you don't do this, then you can just work on it as it is. I just need the verification code or the two-factor authentication. Okay. So you can use a virtual environment. Yesterday you learned about creating virtual or isolated environments, and you can of course use them in batch scripts, and I will show you how. And then I'll also show a Python code that uses Python pandas and matplotlib and how you can make something like that work in a batch script. And this is a very simple example. So, and there's a couple examples. This was covered yesterday. So I forgot to update this. I here have a recap from yesterday of the commands that are most important. And I think that you remember them, but in any case, submit with sbatch sq minus minus me to see a list of your jobs. And those two are the most important for what we're going to work with today. And then the most important thing to know here is that batch jobs are not interactive. You know that. And you know also you need to use batch scripts or batch jobs when you have more resource intensive jobs, or run them through this GFX launcher portal on demand, as was talked about yesterday, since that is actually also using a batch job sort of behind the screen. So the examples we looked at yesterday was simple Python serial codes. There are many other options. You could have, as I mentioned, virtual or isolated environments that you want to include because you have some packages that wasn't installed as modules and some that you might be tweaking and some that is parallel and some that needs GPUs. Those two latter part here, those will be talked about tomorrow. Pedro will talk about parallel jobs tomorrow. I will just show a brief example of how a batch script looks. Otherwise, he will cover this in some detail. And I will talk about how to use Python code with GPUs tomorrow. So, isolated environments. And I don't think you should type along here simply because it will take you time to create the isolated environment, and you also tried creating one of those yesterday. So when you have created this isolated environment, then you can use it in a batch script. And if you are, for instance, it doesn't really matter which center you're at because everything is done the same here and everywhere. So the only thing is you ask for the resources you would ask for. I mean, telling it you're running in the bash shell, the project ID, how long you think it will take to run it, and then asking for whatever resources you need, cores, GPUs, and so on. Then you load the modules you need, and those would be the modules you used when you created this isolated environment. So those modules you used in the creation of that, you load those here. When you have loaded those, you activate the virtual environment, just like you would if you would be working with it in a shell or something. So you simply do source and then the path to your virtual environment bin activate. And when that is done, you are in that you have access to those modules and that you used and those packages you installed yourself. And you can work as if they are there. And you can then run the Python script that are now that you have that are dependent on the packages you installed. So so this is quite neat. You access your isolated environment from the batch script, and there's no problems with that. It's just load the modules you used for it and source it to activate it. And then you run just like you would otherwise. And if you have an isolated environment that you have created, you can test this. For instance, those you created yesterday, you can try and modify the batch scripts for that. And there are some batch scripts that you can use to modify under the exercises directory. Did I copy it here? I need to go to Roger. And here I have also the exercises table. So if you didn't get it with wget, it's available in the root directory of the course project directory on each of the centers except for Cosmos. I have it here. So I would go into day 3 under exercises, and then I would go to the center I'm working at. So in this case, it would be NSC. And there is run serial virtual environment. It's actually this one here. So what you do is you create yourself a virtual environment, take the one you created yesterday, for instance, put in the modules from it here, source it, and then run a Python script that uses it. So that would be an exercise to try if you want to. I will also very quickly mention what happens, what changes you need to do to run an MPI code. And that is because you don't need to change a lot from a serial code. You mainly need to get more cores because you will have, depending on the number of tasks you have, you ask for that. And then depending on the center, for instance, at NSC, you run it with MPI run minus NP and then the number of tasks, Python, and your parallel Python script. There is examples for each of these here, and it's also possible to run it if you want to. They are in the exercises directory. You need to make the same changes you did yesterday for examples. So let's see that one. So you would go into my path and change this my dear name to whatever you call it. And other than that, you can run it. I'm not going to talk about this otherwise today because Pedro has nice material about parallelism tomorrow. So, okay, it is 14:55. That means it is time to take a break. And when we come back from the break, I am going to continue a little bit with a couple exercises, and I will also have the example for how you can run a pandas and matplotlib program as a batch job. But let's take the break now. We are starting up again. So I will be continuing, and I mentioned that sometimes you need to make changes in order to run your Python script in a batch job. And some examples for that is, for instance, if they are querying for input during running, you need to rewrite it if you're doing that, or submit it to the Python script within the batch script because you cannot interact with it. It could also be that they are creating plots and opening them. And of course, you also cannot open the plots within a job that is not interactive. And in those cases, the codes you have need to be rewritten more or less, depending on what you need. So either maybe they take the input from a file or data set, or maybe you give it some argument within the batch script. Or maybe you rewrite so a plot is saved to file instead of being opened directly. These are only some examples. There will be many others, but I'm thinking that these are at least some of the examples you could have. And one example I have is what we also briefly touched upon yesterday. There is a serial script that is asking for some arguments, and that you could rewrite so that you give it the arguments inside of the batch script. And there is examples here that show how you would do that. And I don't know if you tried running that yesterday, but otherwise you can do that. So you could make it this way, where you simply tell it to accept two input parameters, and those you then give it within the batch script. So there's an example for that you can change as you need for each of the centers. And you can also just try and run that and see, just to have a simple example to run for Python here. And you can find it within, again, exercises, day 3, and then you go to the center where you are working. And this example here is called run sum two args. And if you haven't used editors on Linux, then you probably should use Nano. As you probably have been doing here maybe a few days. And you could open it. And then again, as mentioned several times before, the only change you need to do is change my dear name here to what you have. It should have the correct project IDs and things for each center. So I'm going to try and do it here. I change it to the name I chose, and this is NSC, so it's X, like that. And what it tells us here is what is the path to the place where I have the Python programs. And it's simply in order to make it easier. I could also just take this string here and place it in front of the Python script that I have in the programs directory. Or I could have put it in the directory itself, of course. So let's save that. and I will just submit it. And then let's see if it is running yet. It's pending, so let's just leave it there. Then let us look at the other option. Say you have a Python script that is maybe creating a plot and opening it. Then you just need to change it so that instead of opening this plot, it will create a file that you can later open somewhere else. And in order to do this, you need to either be in a terminal window in the ThinLink, desktop on demand, or you can just log in with -X or -Y, so you have X forwarding. You only need it to see how this runs without a batch job. If you are just running the batch job, you will be fine because it will write it to a file. This was just to show how the difference would be. So in case you want to run it from the terminal as a Python script, then you would need to load these modules here. If you're at PDC, unfortunately, you also need to create a virtual environment. But these steps should work. I'm going to try and load this on Tetradit. And then I'm going to start Python. And since I'm just going to show you how it looks here, I am going to go into the programs directory directly here. And in here you have these various Python scripts that are being used in the exercises. So let's start Python. And I'm now inside of Python on Tetralit. So import pandas. It's not fast. And if you want to, you can just code along, or you can do this afterwards. I am going to give you 10 minutes to try these things afterwards. I'm just going to show how the program would behave before you make changes to it. What did I write? I made a dot where I should have made an underscore. So this is if you prefer to work in a terminal and submit things as batch jobs instead of working in, say, a Jupyter Notebook or something similar. And now is the actual problem. I'm going to show it. Let's see if that works. That's right. NSC has, of course, a problem. Let's see what it was. It has a problem with TK inter, but you should still be able to save it. And then you get the plot saved instead. And otherwise, this will open a plot. And I can't show it here because TK inter is not working right now on Tetralit. I don't remember what it was I changed in order to make it work because I will look at it later. In any case, instead of opening the plot, then you simply make the change to save it as a figure, and then you get it saved to something you can look at later instead of having it open it immediately. It's no longer interactive, but you still get the same output, and that is fine. So, and you would be able to put into a batch script. Whereas if you put it in with plot show, it would fail because it will attempt to open the plot, and it can't do that inside of a batch script. So that would be the only change you needed to make. And I have this example here. Pandas matplotlib batch. So let's open it with nano. So as you can see here, you can run it as soon as you are making the change where it will be saved as a file instead of opened as a plot. So make this change here, and then you can run it, and then this batch script should create the same plot, myplot.png, and that can be opened with whatever edit image viewers you have at the center you're working, or you can just download it and open it somewhere else. So this is a way to still run something that was originally interactive, but that you want to run as a batch job. And I would like to give you some time now to work with these exercises. I was going to give you 10 minutes, but it seems that we probably have a bit more. So let's take 15 minutes. And then depending on what center you are, you can either log in with ThinLink or with a portal like on Alvis and Kebnekaise. And if you are in a ThinLink or similar environment, or if you have opened with the SSH minus capital X, then you can take this and do and see it inside of Python, make it plot the make the plot, and then afterwards you can try and run the batch script and see that it creates also a file that is an image that is the same as a plot. So try to at least do this exercise here. And you can also try and run any of the other scripts there if you want to, say, create a virtual environment like you were shown yesterday and see if you can run a Python script with that inside of it. So let's work until 1540. Just a moment. Yeah, let's take until 1540 or 1545. That should give people enough time. And then we will end with the evaluation. Okay, I'm just going to do a quick comment regarding the exercise where you do a matplotlib and pandas Python example where you have a plot that opens and then change it so you can use it in a batch script. So first I'll say that I have logged into Tetralit with SSH minus capital X. And then I am going to load some modules like this. I'm loading matplotlib, scipy bundle, tkinter, and some prerequisites, including the GCC and build tools. And I'm in the exercises day 3 programs directory, where the Python scripts are, and where also this Scottish Hills.csv dataset is located. And I found out that now it's possible to do the plot the same way on NSC as it is on UPPMAX, HPC2N, LUNAC, C3, SE, but not PDC. So that means that there's no longer a special case for NSC, the same works there. So I'm going to load Python, and then I'm going to import pandas sp. I'm going to import matplotlib, and then I am going to import matplotlib.pyplot as plt to make life easier. And then I'm going to use the backend tkag for NSC. It turns out that is actually working for NSC. So I'm setting the backend to tkag. And then I'm loading this data set. Leading in a CSV file, and it's called Scottish Hills.csv. And then X is I'm going to have the height, and Y will be the latitude. We can look in this dataset Scottish Hills.csv and see what is there. And then I'm going to do a scatter plot. It'll take a short time. Or maybe a slightly longer than short time. And then we should be able to see this plot here. And as you can see, it opens slightly slow because it has SSH minus X connection, but not that bad. So it's possible to work with. And if you're doing this inside of ThinLink, it's much faster. Okay, so let's imagine that you wanted to run this as a batch script. Now, a batch script, as you know, you cannot open a plot in that, but you can write it to file. So what would you do instead? Well, you can do exactly the same here, except for the very last line, which is the plotted show. Instead, you would do plot savefig and then name it anything. Scottish Hills plot .png, for instance. And then it will save that. It takes a little while. Okay, so let's exit. And then you can see here, there is now a Scottish Hills minus plt.png plot.